HS 1.2, as I mentioned, you've got the salivary gland overall structure, you've got the acinar cells that produce the enzymes and stuff, and you've got the duct cells which modify those secretions. So let's have a look at the salivary ducts and see how they modify the secretions. Well, the acinar cells, as I mentioned, they produce the enzymes and secretions. They also secrete sodium, chloride, potassium, and water. And this whole thing, there's enzymes and ions and water, this is the primary secretion by the acinar cells. And what happens is, as it passes up through the duct cells modify the secretions. Well, what do? Well, the duct cells, they absorb sodium and chloride, and they secrete potassium and bicarbonate. So if you absorb sodium and chloride, you're going to absorb ions, and if you secrete potassium and bicarbonate, you're going to have alkaline saliva. So the overall result of this modification, as it passes through the duct, this overall modification is the saliva becomes hypertonic, means less ions because you've absorbed them, and alkaline because you've secreted the bicarbonate. And what's the purpose of this alkaline hypertonic saliva? Well, it's got two functions. It protects the teeth from bacterial acid, and it also neutralizes the gastric acid reflux when the food moves down through the esophagus at the gastroesophageal junction. And again, I've written Sjogren's here because obviously it's going to be attacking the acinar cells, so you're not going to have these secretions. So now let's look at some of the diseases. Well, salivary gland diseases, there's two that you need to know about. There's Sjogren's disease, or Sjogren's syndrome, and there's the mumps virus, which causes parotitis, which you can probably guess. It affects the parotid glands, causing inflammation in the parotid glands, itis, right? So Sjogren's disease. Well, Sjogren's disease is a disease in which anti-nuclear antibody, NAA, causes an immune attack on the body, autoimmune even. An autoimmune attack, obviously, we can associate with rheumatoid arthritis, and this autoimmune attack results in an attack on the salivary and the tear glands. If you attack the tear glands, you're going to get dry eyes, and you'll need artificial tears. And if you attack the salivary glands, then you'll get a dry tongue and mouth, which is xerostomia, which you can see here, very dry tongue. This is Sjogren's syndrome. And if you have Sjogren's, you're going to need artificial tears and saliva. So next we can look at the mumps virus. Well, mumps virus, if you get the mumps viral infection, then you get a prodrome meaning early symptoms of headache and fever. And then once you've had this prodrome, then you'll get inflammation. And as I mentioned, you get inflammation of the parotid glands, which is parotitis, causing a dry mouth, which is xerostomia. Remember, the parotid glands, they're the most posterior, so they produce the most serous saliva, so they're very, very watery saliva. So if you attack the parotid glands, it's going to have quite a big effect on how watery the secretions are. You can also get inflamed testes, which is called orchitis. And you can protect yourself against the mumps viral infection by using MMR vaccine. It's going to protect you from the mumps virus. Okay. So having a look at the control of secretions. Well, if you think about it, when you don't really think about secreting saliva, do you? It just sort of happens. So it's the autonomic nervous system, okay? And the autonomic nervous system is made up of the parasympathetic and the sympathetic. Just as a side note, if you're attacked by a tiger, then the sympathetic nervous system is sympathetic to your cause. It wants you to live, so it's going to want you to stop digesting food, and it's going to want you to get a move on by getting energy to your muscles. Whereas the parasympathetic, it's not sympathetic to your cause. So when you get attacked by a tiger, it's not parasympathetic to your cause. It wants you to die. It wants you to salivate, and it wants you to start digesting, right? So, in terms of the autonomic nervous system and control of secretion, it's mainly going to be the parasympathetic, right? So if you stimulate the autonomic nervous system by whatever means, then you'll get parasympathetic stimulation. And this will involve two cranial nerves. It'll involve cranial nerve 7, which is the facial nerve, and it'll involve cranial nerve 9, which is the glossopharyngeal nerve, right? When you stimulate the facial nerve, it will stimulate the submandibular ganglion. The facial, near the face, submandibular ganglion lies at the base of the mandible, and it will go to two salivary glands, go to the submandibular gland and also the sublingual gland, causing secretion. The glossopharyngeal nerve, cranial nerve 9, when you stimulate that through the parasympathetic nervous system, it will go to the otic ganglion, which supplies the parotid gland. You can remember that by otic, parotid, OTI, it's the same sound. So that's the parotid gland causing secretion. Now, if you stimulate the autonomic nervous system, causing sympathetic stimulation, then that will cause thoracic spinal nerve stimulation. If you stimulate the thoracic spinal nerves, that will go to the superior cervical ganglion, which is upper neck. It'll go to the all glands, and it's going to want you to stop secreting, as I mentioned. So you're going to get vasoconstriction and thick mucus secretions, because you're making less of those enzymes that us in our cells are being stimulated less. How are you going to stimulate the autonomic nervous system? Well, you're going to stimulate it through thought, touch, and taste. It can either be conditioning, because you're conditioned to associate touch and thought of food with food, and also higher inputs, like you're controlling the autonomic nervous system. Or higher input even, so like when you're thinking about it, right? And as I've written here, parasympathetic predominates the sympathetic. Okay, so now moving on to the swallowing phases. So essentially there's 4 phases. You've got the oral preparatory phase, you've got the oral phase, which is when the food's in the mouth. The food then moves back to the back of the mouth, oropharynx, that's the pharyngeal phase. Pharyngeal phase being the most complicated, it's the pharyngeal swallow reflex. And then finally you've got the esophageal phase. So looking at that in a bit more detail. Food is masticated in the mouth to reduce the consistency to the right level, increase surface area. That's the oral phase, oral preparatory phase even. The tongue then propels the bolus posteriorly to the back of the mouth, to the palatoglossal arch. That's the oral phase. And once it goes from the mouth to the pharynx, well, it's the pharyngeal swallow reflex. What happens? Well, the glottis moves over the glottis, causing closure of the trachea, causing you to stop breathing. The bolus of food will be transported through the pharynx by peristalsis, using the constrictor muscles, upper, middle, inferior. And the upper esophageal sphincter will relax to allow the food to pass from the pharynx into the oropharynx, right? And once that's the pharyngeal phase, so once you've swallowed it, then it'll pass into the esophagus through the upper esophageal junction. And in the esophagus, as I mentioned right at the start, it's peristalsis to take the bolus of food from the upper esophageal sphincter to the lower. That's the esophageal phase.